let's call this here significant digits. Here is your title. Significant digits. I'll give you a second to take a deep breath and take that all in.
Yeah, need a little.
Got it? Okay. Here is the deal with significant digits. And just like the word sounds, when you think of the word significant, it kind of means digits that matter. Okay? This comes into play only in measuring things. Okay? Only in measuring things. Because when you measure things, you can only get as accurate as the scale that you are using. Okay? And you can always use a smaller scale if in fact you had one. In other words, if you were measuring a line, and your ruler only had centimeters in it, okay, maybe this thing is 6 centimeters long. But if the ruler you were using actually had millimeters on it, maybe the thing is actually 58 millimeters on it. And if by some chance you had a ruler that had millimeters cut into tenths, I don't know what those would actually be called, but you know, you could actually say maybe this line was 57.3 or 57 3/10 millimeters or whatever it is. Okay, because you can only get so accurate with measuring devices, you have to be careful with when you start working math with those numbers that you measure. Okay, and I'll explain it a little bit more a little bit later here. But here are the rules, and you need to kind of see these rules. First of all, let me blow them up a little bit. Right, jot these down. No boy.
Yes.
I blame the board mostly. There we go. Okay, first of all, they give you some examples here, so write this down. You count all non-zero digits. Okay, so if there's no zero, you only have to worry about significant digits when there's actually a zero that appears in the number. Okay, for example, 254, no, don't do it. It's right here, oh, look at that, good job. If you have 2.54, which is how many centimeters are an inch, there are in that thing 3 significant digits, 3 digits that count. Okay, there's no zeros there, we don't have to worry about that. Okay, you do count zeros that fall between non-zero numbers because they're actually placeholders there, they actually mean something there. Okay, so when you have 10.7, okay, that 0 is also called a significant digit. So this one also has 3 digits. And nothing but okay. You also count trailing zeros in decimal numbers. Okay, so if the 0 comes at the end, it counts. Okay, if the 0 comes at the end, it counts. So this one again has 3. Okay, now you're saying, well, when don't you count these? What did I say that? Well, I'll tell you here, we're getting to that. Okay, you do not count zeros if there is not a non-zero digit to the left. In other words, when you have this number here, okay, you look at the zeros. If there is no digit that's not a 0 on the left side of it, you don't count those zeros there. Okay, on the right, they get counted. On the left, they don't. So this thing right here only has 2 significant digits. Count them when they're on the right, don't count them when they're on the left. Trailing zeros of whole numbers are, oh, I like this one, ambiguous. Okay, in other words, when they're trailing, when there's no decimal point and it's just the whole number, This is saying you really can't, it's ambiguous, so you don't really know. So there you just wiggle your brow and go, I don't know how many significant digits are there. But it says you can fix that if you write it in scientific notation. If you write it in scientific notation, notice here, if it's written in scientific notation, then you count 3 digits there. Okay, but if it's written like this, you don't know. It's got to be at least 2, can't be any more than 4, but there again, I only done this once in my life, so I'm do the best I can with this. And then the last one says, exact numbers have an unlimited number of significant digits. In other words, if you're talking about something that's already exact, like if you're counting apples and I have 5 apples, okay, there's no ambiguity there. I can't use a different scale that would say there's 5.2 apples there. There are exactly 5 apples there. Okay, if it is an exact number and you know it, and that would come when you're not talking about measuring, counting things would be whatever, then you don't worry about the significant digits of it. It just is unlimited. Okay, for example, it says exact numbers include exact conversions. You know that there are exactly 3 feet in a yard. Okay, so that's an exact number there, because we know there are 3. Now if I was measuring a 3-foot piece of string, there again I can only get so accurate with my measuring device, so then you'd have to look at them as significant digits. But if it's a conversion, it's a little confusing because you look at these and you go, well that's a measurement. No, it's not, it's a conversion. You know there is exactly 3 feet, so you don't count significant digits in that. Maybe this will make some sense when we look at it here, because I know right now you're staring at me going, yeah. Okay, just looking at significant digits here. Mrs. Stone, what do you remember about significant digits? And you do this because it's a science thing.
I got nothing.
I told it, well, I know. I said I remember.
Listen for a second.
I said I remember doing it once in high school, talking about significant digits. It's in measurement. Well, and here's really the real deal with it, okay? If you're measuring something, let's say you're taking, and one of the problems in the books comes up with a cube. A cube that you measure with a ruler to be 1.2 whatever centimeters on a side. If I asked you to find the volume of that cube, what's going to happen? What do you do to find volume of that? Length times width times height, so you get 1.2 times 1.2, which is what, 144, decimal point there, and then 1.2 times that, you get what, 882, and then 144, which is what, 827. You get 1728, but where's the decimal point go there? Somebody? I had 3 decimals there, so where's the decimal point go? Right here, right? The problem with that is this. In the things that I multiplied together, I only measured to the nearest tenth. But when you do the volume and you multiply all those decimals, it gives somebody the opinion that you measured out not to the tenths, but out to the thousandths place. Okay? Because as you multiply decimals, they get bigger and farther away and whatever. So you can't do that. If you're actually measuring something, you're not that accurate as to how much, because if this was off a little bit and you measured, instead of measuring to the thousandth or whatever. So the rule says this, in your answer, you can only have as many significant digits as the least significant digit that you multiplied together here. Which means this, you look at all these things, how many significant digits would be here? How many non-zero digits? 2. So there can only be 2 significant digits here. So you have to cross these off because you can't count them because you don't know for sure that those are accurate. You can only list this as being 1.7. And again, that's only when you measure things. It's not if I was just multiplying 1.2 times 1.2 times 1.2 of whatever things. It's only when you're measuring something that you don't know for sure if it's exact because you can only measure it to certain things there.
That's easiest.
Yeah, well, not so much. Nathaniel?
Can you go back up to rule 5 when you finish writing that down?
Yes. Yes, I will go up to number 5.
Thank you.
But oh, Mrs. Stone, did you have a question? I want to keep you here
Did
forever.
you pick up those sport night plates from the?
Yes, I put them in the cabinet that says sports in the kitchen.
There's a cabinet?
One above that one sink that's As you walk out that door, there's a sink on the left that says sports and concessions or something up there.
Perfect.
So I jammed
That's
that
awesome,
up there.
because those should last us, then, those the next one. the next
I don't know if that's the best place, cause I know somebody pillaging through there probably would take them and use them for themselves, but we could take them and put them back
one.
here.
That's right, can I leave this with you?
Yep.
Okay,
Yep.
water.
Lauren,
Two questions, so if you put 1.200, you could do
well,
Without a zero.
if, well, adding zeros count because you can measure to know places there. First of all, to put 1.200, were you saying?
Yeah.
Okay, that's telling somebody you actually measured to the nearest hundredths place. And if you multiply those three numbers together, you will get this same thing you had here, which was what, 1728. But then you're gonna end up with 246. When you multiply that, you're gonna end up with 6 decimal places.
won't
Actually,
they
we
be
could
all
add 3
zeros?
zeros, 1, 2, 3 zeros.
but you can cross those out and then you get
But then, well, I must have done this wrong. But then you still have to know that the least significant digits I have here are 3. So then the least significant digits I have here, I would have to cross off that final 8, and then this would be my answer. Because 3 is the least significant digits here, it has to be what the significant digits in my answer are. How's that? Anybody dazed and or confused? Again, remember, this only applies when you're actually measuring things with some sort of a scale.
So you
It
don't
doesn't
have-
apply if you're just normally, if the book says multiply 1.2 times 1.2, you get your whatever answer you get. If it says, like this one, the diameter of a quarter is about this, okay, then you'd have to consider what are the significant digits in that. And this one only has 2 significant digits. A ruler, and here they throw these little ambiguous words there. If it's about, how many significant digits is that? 3. There's average distance, 9.3 times 10 to the 7, how many significant digits? Just 2. A mile is 5,280 feet? No. This is a conversion. This is an exact number. I know that there are 5,000, I didn't measure this. This is a unit of conversion. This has unlimited. You don't count the significant digits in this ever, because it's a conversion. It's an exact number. Just like I know there's 3 feet in a yard, I know there's 10 millimeters in a centimeter, I know that there's 12 things in a dozen. It's an exact measurement. You didn't have to sit down there and take a ruler and measure those 5,280 feet. Okay, it's an exact measurement, and you don't count significant digits for that. They don't count in that. Like the book says, it's unlimited. You don't, whatever. I can tell there's still a bit of angst out there. Whatever angst means. Right, and here it says, when performing calculations with measures, scientists are careful not to include more digits in the result than are justified. Okay? So you can't give an answer that looks like it's more accurate than the measurements that you took. And I wish I could, off the top of my head, come up with a great example for that. I can't, so I won't try at this point. Maybe I'll think of it. Chupa. Get out of here. Question there? I don't think it's going to be as hard as you might make it look, because there's just a couple rules you have to follow. And it only applies, the book will tell you when you apply it, so it's not like you have to say, am I going to use this here or not. Lucas?
Well, say you had like a 3-digit number, but when you like multiplied it out, it ended up being a 4-digit number, and the point was like after 3 digits.
Let's look at that. Now, this would have to be something that you measured. Let's say you measured the top of your desk table and it was, I don't know, let's do it in meters, 1.35 meters, right? And you said if I put 4 of those desktops together, no, let's go 8 of them. If I put 8 of those desktops together, how long would my thing be? How long would a line of desks would it be? Well, you multiply this out, like you were saying, 8 times 5 is 40, 24, 28, you carry the 2, you get 10, right? And the rule is this, well the decimal goes here, the rule is this, the rule was, this has how many significant digits? It's a measurement, so in my answer, I'm only allowed 3 significant digits, so you'd have to say you can't count this 0, this has to be your answer. And had that been a different number besides 0, you'd still cross it off anyways, because you're only allowed those 3 significant digits, because this was a measurement that you made times 8. This doesn't count for significant digits because it's an exact number. I know there's 8 desks, I didn't measure 8 desks, it's a countable number, it's exact.
Well, what if like it ended up to be different, there were 3 digits before the decimal and then there was a digit
Then you can only count 3 digits before the decimal. If this would have been only 2, then you can only count the 10. It'll work out for you, I think, more than whatever. Lauren?
So you don't round, you just get rid of it? Okay, and then,
I believe, I'm gonna look at that again. Let me look at their examples. Do you round is the question on the table. Ladies and gentlemen, do you round? And you know they're not gonna give me one that has the actual thing here. Hold on a second. I'm gonna say right now, no, until I'm proven different.
Yeah.
Do I think that Arthur Fonzarelli could be wrong on that? Yes. I think you just cross him off, Lauren.
so back to the thing that said like 2.5 is about, or like a quarter is about 2.5, what if it said it is 2.5? Would you still think that it was a measurement?
Yes, I think even if they said is, because, well, no, I think if they tell you it's exact, then you have to go that it is exact, yes. So I don't think there's any significant digits there. If they say it's exact, like it said, if it's an exact number, then you go with exact. If they're saying about, or if you actually measured it, then you have to go significant digits. Now, here are the rules that you need to write down, okay? When you multiply or divide 2 measurements, okay, that's the one we just talked about, you can only have as many significant digits as the measurement with the least number of significant digits. Write that down and I'll tell you what it means. Okay, let's say you have this measurement, 3.84, and you're multiplying it by 2.6. Okay, what that says is this. I'll let you write it first. So few times, so little to do.
Wait, shouldn't you put the 2.6 under the 8.4?
It doesn't matter. Yes, ideally, it doesn't matter, but yes, ideally, Jack, I didn't mean to line up the decimals there, I just happened to. Forgive the error on the ways. That didn't really work the way I wanted it to. I wanted to take the 6 and move it over here. Put that decimal there. Okay, the deal, what that says is this, okay? Let's say both of these were measurements, okay? Both of them were abouts, both of them, okay? This has 3 significant digits, this has 2 significant digits. You can only have in your answer the number of significant digits as the one that has the fewest significant digits in it. Which means in my answer, I'm allowed to only keep 2 because it is the smaller of the 2 numbers. Okay, it's the one that has the fewest significant digits is how many digits you keep in your answer. Jackson.
What is that?
Huh?
What is that?
Because this is the least accurate one that you have to go by. If you went by this one, then you'd be giving somebody an answer that might look to be more accurate than it really is. Okay? It's like your team is only as strong as its weakest link. You can't be stronger than the weakest link. And this is the weakest link. This is the most accurate you can get with 2 significant digits. You can't be more accurate than those 2 significant digits. Had there been a 0 at the end of the 6, then you could have kept the 3 digits because they both had 3 significant digits. Lauren?
So, does that only work for decimals? Because what if we have like 12 times 12 and then you have 144? Is it only 140 then?
Well, 12 times 12. Again, if it's a measurement, 12 times 12 is 144. How do you keep just 2 significant digits there? Didn't it say, wasn't the rule if it was a whole number, it had an infinite amount, or what's it say? A whole number, it said, could have, what was the rule? It said it could have
So,
Unlimited number, is that what it said? Yeah, I think we're talking specifically with decimals here, I don't think you have to worry at all with whole numbers. Alright, now, let's do the addition one. The addition one says this, addition and subtraction is the same rule. A sum or difference may show no more decimal places than the measurement with the fewest number of decimal places. And that's, I guess, that's the same as decimal places, I guess. In other words, they give the example there. Okay, when you're adding 6.24 plus 4.6, 6.24 plus, what, 4.6. What they're saying is this, if you're adding these together, it's not even so much a question of significant places, it's a question of the most accurate you can get is in the tenths place. Because whichever one has the fewest number of decimals, that's what place it goes to. So you end up with 4, 8, and 10. You have to get rid of this 4 because you can only have one decimal, one place after the decimal. 6.24 and 4.6. Because this only has one place after the decimal, your answer can only have one place after the decimal. Sage,
yeah.
you have a question? Understood?
No.
It's vague at best, yes. Lauren? No, it'll
So
get
like
better.
if you were doing a science experiment and like you had those measurements, would you probably want to put the 0 there? Like,
Well, and would you want to put that 0 there? Well, you'd have to make sure that whatever you're measuring with is measuring to the hundredths place.
well,
You can't put that 0 there unless you know for sure that it is not 0 hundredths there. Okay, and that's what the whole gist of this is getting to. You know, if you measure one thing to the hundredths place, but the other thing you only measure to the tenths place, you add those together, you're not sure that your hundredths place digit is actually accurate when you put them together because you didn't measure that one to the hundredths place. Maybe it was 300ths over there, but you didn't have that or didn't measure it to that, so you can't tell the person when you give them their answer that it goes out to the hundredths place, because then they're assuming that you measured everything to the hundredths place and you really didn't. That's kind of the gist of the whole thing.
so why wouldn't you do everything to the same thing?
Maybe you didn't have, maybe the first one was measured by somebody else and you had, the other one was measured by you and you didn't have hundredths on your ruler, I don't know. I guess it must happen, I don't know, I didn't make these rules, people. Didn't write the book. Emma Christ,
So the answer to that one was 10.8.
it's just gonna be 10.8, yeah, because you can't go any farther than that place there. Let me give you, let's do a couple of the practice problems on the sheet there, turn this off.